All right, let's wrap this one up. We got one more thing that you might want to look for, and it's substitution with trig identity. So we start off with isolate if you can, right? And then we tried factoring, make sure that's set equal to 0. Square root property is when you have a sine squared or a cosine squared or a tangent squared, but there's no other functions running around. Like there's not a sine squared and a sine to the first. So you're kind of, with quadratic equations, we were looking for something that did not have a linear term or an x to the first to use the square root property. And the same is true for this when we use trig equations. All right, we can also do substitution with trig identities. Some things that we know. So let's take a look at this one. Factoring kind of looks like it's out of the question. No way we're going to isolate. Square root property, there's two different trig functions running around. So substitution, I think, is going to be the order of the day. The idea is if we can substitute a sine for a cosine or vice versa, cosine for a sine, we can at least be dealing with one trig function. That's much more helpful. So we have two options. We can either call this 1 minus cosine squared, or we could call this 1 minus sine squared. I think the path of least resistance is we're going to make this 1 minus cosine squared. And we'll keep this as plus 3 cosine squared. Not saying it would be terrible if we made this 1 minus sine squared, but then you would have to distribute your 3. It's just one extra step here. Where here, I can just combine them. So I get 1 plus 2 cosine squared x equals 2. And then we can see we're going to probably do something like the square root property here. Let's isolate cosine squared. So I'm going to subtract 1, divide by 2. Now be careful. A lot of people stop here and they think, oh, so cosine is 1/2. No, cosine squared is 1/2. That means cosine is plus or minus the square root of 1/2, which is square root of 2 over 2. So cosine of x is plus or minus square root of 2 over 2. Should recognize that one, but we'll set up our 2. So we got cosine of x equals positive square root of 2 over 2, or cosine of x equals negative square root of 2 over 2. Okay. Again, solving these for principal values. Hopefully you're starting to understand. This means the cosine inverse of square root of 2 over 2. Again, we're not wasting our time. Even if they say, I want you to solve between 0 and 360, you're not wasting your time because you're actually finding either one of your solutions, 0 to 360, or a very strong clue. In this case, it will be one of our solutions. Cosine inverse of the square root of 2 over 2 is 45 degrees, or pi force in terms of radians. Right? Cosine inverse of negative square root of 2 over 2. Again, careful. You're going to quadrant 2, and this would be worthwhile, again, to see on the old calculator. Your calculator operates on these inverse functions, so it does operate on the principal values, I guess is what I'm trying to say. So let me type in negative square root of 2 divided by 2. Looks kind of bad, but there it is. Negative square root of 2 divided by 2. And we'll just hit enter, and you'll see we're going to get 135 degrees. Yeah, prove me wrong. Obviously, my calculator is in radian mode there. Quit. Oh, no. Look closely. I did cosine, not cosine inverse. Shame on me. Second, cosine inverse. Well, this is a lot more than what I want to do. Okay, we're here now. Square root 2 divided by 2. That should work. If it doesn't, there we go, 135 degrees. Why is that true? Again, let's go through the math real quickly because this is important. It's either going to throw you in quadrant 1 if it's positive like it did here, or it's going to throw you in quadrant 2. Now, we'll use that 45 because I said pretend like this is positive. Well, you got 45, but in quadrant 2, you got to go with the reference angle. So it's a reference of 45 in Q2, which does give you that 135-degree answer that you saw in the calculator. So we got 135, or that is 3 pi fourths. Hopefully that's not off the screen, is it? No, just we got it. 3 pi fourths. All right, going 0 to 360. X less than or equal to 360. All right, if we go to the 0 to 360, 45 is an acceptable answer. I'll use it. Question is, where else is cosine, go back up here, where else is cosine positive besides quadrant 1? Well, cosine is also positive in quadrant 4. So a reference of 45 in quadrant 4 puts you at 315 degrees. All right. If we go over here, 135 is an acceptable answer between 0 and 360. I'll use it. Again, we're talking about a reference of 45. Where else is cosine negative besides quadrant 2? The answer is quadrant 3. With a reference of 45 degrees, puts us at 225 degrees. And then finally finishing it off, what if they ask for radians? Okay, in radians, 45 is pi fourths. 315 is 7 pi fourths. 135, you are 3 pi fourths. And 222. I could have sworn I said 225. Sorry, 225. 225 is 5 pi fourths. There you go. All right. See if we can't sneak one more in before the end here. All right. Last one I got for you till the next set of videos, which will be more advanced techniques. What do I got? Here we go. Sine. 2x, nothing suspicious there, plus the cosine of x equals 0. Well, you can see that we're definitely going to need a substitution on this one. Why? Well, you got a sine double angle. Those are never fun. So let's rewrite this sine double angle. Look back on that sheet from last chapter, the trig identities. This would be sine of x, cosine of x. That's sine double angle. Plus the cosine of x equals 0. That's what I have. So always do those obvious ones right away. All right, looking at this mess, I'm thinking, why not try factoring? It is equal to 0. We can factor out a GCF of cosine. I think we got something. Factor out a cosine of x. You have 2 sine of x plus 1 equal to 0. Set both of your factors equal to 0 because that's the whole point of factoring. 2 sine x plus 1 equals 0. Let's finish solving this one. I'm just doing the isolating step here. Subtract 1, divide by 2. So cosine of x equals 0. You are talking about a quadrantal angle. It might be worthwhile to give a little sketch of cosine. I'm just going to sketch the cosine. 0 to 360, just so you can kind of know this one. There's 2 pi, there's pi. Cosine starts off at the maximum, drops. So that's really all we need. Okay, so when we do cosine inverse of 0 for principal value, probably should move that over here. Take a look where cosine is 0 at. Well, it's 0 at 2 locales. It's 0 at pi halves, and it's 0 at 3 pi halves. But your principal value can only give you one of those answers. And remember, it's either, well, it's got to be between quadrant 1 and quadrant 2. So pi halves is the only acceptable answer, or 90 degrees. So when we go to principal value here, we're doing the cosine inverse of 0, which is, 90 degrees or pi halves. over here, sine inverse of -1/2. Again, that's going to throw you into quadrant 4. The principal value will be -30 or -pi6. pi6. I really shouldn't be putting a comma. It's an or, depending on whether they want degrees or radians. Right? So -30, we got to go to quadrant 4. If we go 0 to 360, 60. Well, now here's where the graph helps. 90 is acceptable. I'm going to use that for sure. 90 is between 0 and 360, and also at 3 pi halves. Cosine is 0. So that would be 270. Then over here, well, can I use -30? Of course not. It's not between 0 and 360, so we'll use that as a clue. Reference of 30 in quadrant 4, so we'll say 330. As well as, where else is sine going to be negative besides Q4? The answer is, well, in Q3, it's also negative. So there's 30 degrees. We're looking at 210. And the rest is fairly easy. Just convert those to radians if they ask you for radians. So radians, what are we looking at? Looking at pi halves. We're looking at 3 pi halves. 330 would be 11 pi 6. 210 is 7 pi 6. And those should be your solutions. All right, that kind of wraps it up. Try some of the homework. Not some of it. Try all those problems. If you notice the front side, I think they ask from 0 to 360. And on the back side, it's 0 to 2 pi. It's just on the back side, you just got to go that one extra step. I would still go through this procedure, find the principal value that helps you on this. And of course, once you get the degrees, you can easily convert them to radians. Right? There's some off brands that they use with cosecants. Try to suffer through those. How I would handle a cosecant, for example, let me just give a quick one, and then we got to end this thing quickly. For example, I have a cosecant squared. Theta minus 3 equals 1. Okay, first step, let's use the square root property. So cosecant minus 3 cosecant squared. Yeah. Cosecant squared theta equals 4. Square root cosecant theta equals the square root of 4. Well, we go plus or minus 2. Now, for this particular one, you say, okay, that's pretty weird. How do you do an inverse cosecant? I suggest you don't do an inverse cosecant. I suggest you write this as 1 over sine equals plus or minus 2. And then one of the things you can do to both sides is take the reciprocal. If you take the reciprocal of the left side, you get sine of theta. You take the reciprocal of the right side, you get plus or minus 1/2, which is much more preferable than what we had originally in cosecant. Sorry for running long on that one, but that's how you handle the off brands.